Howdy and welcome back. So let me pull up where we are and where we've been. So in the last video of this lesson, we talked about the preprocessor. We talked about the importance of the include guards. We talked about a number of different preprocessor directives, including the pound include, what's actually happening behind the scenes with that directive, as well as the ability to introduce a conditional into the preprocessor uh, stage of the game, as well as the ability to define preprocessor variables and essentially branch based off of whether or not those variables have been set or not. So now we've gone through the preprocessor stage, so we have an expanded source file or a translation unit. We're now going to look at what happens when that translation unit of a single source file. So I'm just going to look at main again, and we won't worry about our definition of, say, square until we get to the linker stage. So we're just looking at how main's going to flow through the compiler stage. So back over to Visual Studio Code. So at this point, I took out those additional header files that were kind of nonsensical with those boring functions so that we could just focus on maybe something that looks a little bit more like a sensible program. So the only header file I'm going to be concerned about is utilities.h, which again, now has those nice include guards. I removed the statements for those kind of illustrative header files, and I've simply provided the declaration of square. We're only looking at a single file going through the compilation pipeline. So I'm not going to worry about utilities.cc just yet. And I will show you when we hit the linker stage why we have to send both main.cc as well as utilities.cc through the compiler and specify that both need to be compiled down to object code. But right now we're just focusing on main here. So notice that the declaration is going to have everything that the compiler needs to do its job. What is the compiler's job at this point? Well, it's going to do two things. It's going to look at the syntax of our source code and make sure that, hey, we're writing in valid C++. The other thing that it's going to do is ensure that we are using these types correctly, so type checking. In addition to this, the output of the compilation stage is going to be assembly code. So let's go ahead and look at this. So here's our compilation command. We're using the 2020 version of C++. We are compiling main.cc. This -s means we're going to stop after the compilation stage. So we're going to let main.cc go through the preprocessor. It's going to become a translation unit. It will go through the compiler and will stop right when that assembly code is generated. And we're going to store the output of the compiler stage in main.s. So if we go ahead and run this, we can see that here's my output, and here's the assembly code that's generated from my main.cc. If you look here, it's those mnemonics, just as we talked about. You can see there's a bunch of stuff kind of going on. I'm on an Intel processor, and I'm not even going to bother getting into this. I'm simply showing that this is indeed what is actually generated. But let's go ahead and look at a couple of other things here. Some of the other responsibilities of the compiler. Let's say I forget to include that semicolon. So this is no longer a valid statement in C++, and if you notice, it's going to run into this return statement. So when I attempt to run through the compilation stage, you can see that it is indeed checking that syntax. And if you notice here, the actual output by the compiler is quite informative. It's saying, hey, you know what? I was expecting that you have a semicolon at the end of this declaration. I didn't find one. So maybe you should go to line 5 and add a semicolon. Okay, I'll do that. Let's say I write another nonsensical statement. That's not a valid statement in the C++ grammar. If you notice here, my IDE is definitely catching these. And if you notice up here, well, why is that squiggly? It's angry with me because I shouldn't be using magic numbers. So that should be a constant or read in from somewhere. But that aside, let's go ahead and run this. Okay, so a couple errors here. First one is it's complaining that the result of an expression is unused. Okay, that's fair. Okay, that's fair as well. But if you notice here, the compiler is essentially communicating that, because there's no operand or operator separating these operands, it's expecting a semicolon right here to turn this into a valid statement. Alternatively, if we were to not catch that, maybe we mistyped the actual inputting the operator into the statement. If we were to go ahead and do that, you can see here that, okay, that solves the actual error that was inhibiting compilation from taking place. So that's syntax checking. The other thing that can happen, or what the compiler is going to be responsible for, is going to be type checking. So let's go ahead and include string for this sake of illustration. So string name equals Michael. Okay. Let's go ahead and go name plus equals my last name to simply perform string concatenation. Okay, this is valid. If you notice here, it went ahead and generated assembly code for that. If you're interested in looking at that assembly code, well, here it all is. You can see that because we've now included a standard library header into this, the contents of that file are pulled into that translation unit, and assembly code is generated for it, in addition to the things that we're actually doing in our main, wherever that might be. But that's not the purpose of the illustration here. The purpose is that, hey, in this case, we're using string correctly. Let's say, just for illustration purposes, we want to try to subtract NOAC from that string that I just made. Notice here that we have a compilation error. The reason why compilation did not succeed through the compilation stage here is because the compiler is saying you're using this type incorrectly. A standard library string does not have this operator defined for it, meaning this is not a valid operation. And guess what? You're not going to be able to compile this. So the two things the compiler stage is actually doing, as we noted here, is it is going to do that type checking, as well as it's going to ensure that you are writing valid C++ statements. Notice I said nothing about semantics, and that's where bugs can come. You're writing valid statements, but you're not, the meaning of those statements is perhaps not what you intended. So without ado, I'm going to stop this recording, and then we'll move on to the actual assembler here next.